Hi, today I'm going to talk about the metallization of the purification technology. The metallization is when we make a device, they need to contact each other. So we use the metal to the surface or silicon or other device to the contact each other into connection. So this is the cross-sectional view of the entire chips. You can see the red line. Below the red line is the device. There has a equal the front end line. There have a device and other things in the working. So upper the red line, there we call the back end line. So there is an interconnection and other packaging things in there. So what is the application of the metallization? At first, we use this make a gate and electrode, and normally interconnection, we make an interconnection, and rarely micro mirror in the process of the MEMS. Okay, metallization is separate to the early and current. The past time used the non-planar metallization. Non-planar metallization is literally non-planar state, and we contact to the metal and the that surface. So it makes other problem because there is a difference of the height. So it makes a density of focus problem and other things. So we use should have to solve this problem. So we use the CMP, is chemical machine polarization. So we make a polarization to the surface. We make a mold from the ILD process and polarization to the surface. And last, we fill the metal to the what we wanted, what we want to setting up. And aluminum spiking and electromigration. Why we talk about these things? Because we, in the past time, we used the aluminum to the metallization, but the aluminum has a several problem. Is uh, first is the spiking, and second is electromigration. Okay, AI aluminum spiking is SI absorption into the aluminum, so it makes a spiking figure. So this is cause the in through the junction and other leakage problem. So and electromigration is a mean there when they force to the electric field, their metal atom is it have a move because the electric field. So it makes there has a empty space and there's much more atom in the line. This point is have a several problems, so we rarely use this in the process metallization. And contact issue is this the very very contact resistance is as we should have to solve problem thing in metallization because it have a relation with the device's performance because the resistance relate to the act frequency. So act frequency is faster. It make a device performance is better. So we saw this the contact contact resistance, we use the ohmic contact. What is the ohmic? So we can see when the metal and Si we junction to the two different material, they have a different work function, so have this energy band problem is occurred. So it functioned as a diode process. So it makes you can see this thing is work like this. So we solve this problem. We use the heavy doping into the surface. It make energy band is more bending and and electron tunneling to these other materials. So this the function of the diode removes, then it have a ohmic characteristic. So this graph is a ohmic characteristic we call. And it is the important thing in the metallization, what metal we use. So the metal has a good conductivity. It means less resistivity. So we can see the silver and gold. This is so small resistivity, but we can't use this thing because of cost problem. So we use the copper and tungsten in this time. And next is silicide. Silicide is a important thing in the current fabrication technology because the silicide is a compound that has a silicon and with metal. So it has a characteristic of the metal and characteristic of the silicon. So low resistance, and when it combined with the silicon, it makes a reduce the problem of the interface. And I can show you the several contact ways. First is the MIS contact. MIS contact is also reduce the contact resistance. There is the metal, insulator, and silicon. There's a metal, and we put this surface into insulator. It makes a more tunneling, and it can movement of the electrode, and it can improve the conductivity and it makes the path of the electron. So it reduces the resistance of the contact. And tungsten plug, when we contact to the source and drain, we use this via. This is the tungsten plug. So but there's a several things we should care. The tungsten has when the tungsten match to the oxide, there have many resistivities occur, so it make a tungsten oxide. So we prevent this thing. We make a barrier metal to the tungsten because tungsten to prevent becoming tungsten oxide. So there's other ways of the covering the metal is electroplating. Electroplating is Why we use this technique? Because this is very cheap and very fast, and it makes there is metal on the surface. And in the electroplating, there's a damascene process. Why we use this damascene process? Because we use the metal is copper. We usually use the metal copper is to metal. So, but the copper has a disable to the dry etching. So we use this damascene process. And also we metallization and we making when we making interconnection between the things, we should consider the RC delay and power dissipation. This is important because the strongly related with the device's function and performance. There is you can see the layer between the layer and line between the line. They have a parasitic cap. We should have to reduce this the capacitor. So how we reduce this capacitor? We use the low K material to the fill this area. So usually use these low K materials as void or other thing. Okay, thank you, and this is that done.